Hi guys. Okay, so before we get started with the book, I always like to include this quote in my class. And to explore technology for me is something that I have to do. Otherwise, I feel completely left in the back, abandoned. I think this quote is really relevant to society and technology today. Technology plays such a huge role in our everyday lives. Whether we like it to or not, it's there and it's not going anywhere. So it's important to learn the history behind it and learn what's currently going on with it. What could the future hold? Okay? You don't want to get left behind. So hopefully this class will get us all on the same track and helping, you to learn more about technology and computers. So this is Chapter 1. What is a computer? The objectives, we're going to explain the functions of a computer. We're going to describe the evolution of computer hardware, describe how computers represent data using binary code. We're going to look at the different types and characteristics of PCs, give examples of other PC devices, look at the various types and characteristics of multi-user computers, and we're also going to explain ubiquitous computing and convergence. So if I were to ask you what a computer is, I'd like for you to simply tell me that it is a data processing device that performs 4 major functions. So what are those functions? Well, we can actually think of them as steps. These 4 steps are input, process, storage, and output. And collectively, we call these steps the information processing cycle. During the input stage, raw data is collected. And when I say raw data, I just mean unprocessed data, okay? Our second step, that raw data is then processed into meaningful information, okay? They put it into a meaningful arrangement that now makes a little bit more sense than the raw data we started out with, right? The third step is the storage stage. Data or information is stored for later retrieval. Finally, in the output stage, this processed raw data, which we now call information, is returned to the user. The results are presented. And just as an FYI, sometimes a 5th step is added, which is the deletion or the archiving of data. There's so much data out there in the world right now that occasionally some data does need to be deleted, though the majority of it is archived. All right? So does anyone know the difference between data and information? Is there a difference? There most certainly is a difference. All right? In computer science terms, data is just a representation of a fact, a figure, or an idea. Data can be a number, a word, a picture, even a recording of a sound. Information is simply data that has been organized or presented in a meaningful fashion, such as this amazing PowerPoint, right? Ha ha ha. So here's a figure for you to see, okay? This shows you the information processing cycle, just a little bit differently for if you're more of a visual learner, all right? First step here is the input step. The data is collected from a custom order form. So let's pretend we're going to order something online. All right, you find out what you want to order, and you go to your cart, and you go to checkout. It's time to enter in your personal data, okay? Next step is processing. So the data that you've just entered is manipulated or processed so it can be used to evaluate your order. So in this case, is your credit card valid? Does the zip code match the zip code on your credit card billing address? Things like that. Okay. Here we have storage. So this raw data that you inputted into the customer order form is stored temporarily and then until it can be processed. Okay? The process information is then stored for later retrieval. Finally, we move on to our fourth step, which is output. Okay? So the process data, which has now become information, is output to the store employee in order for them to fulfill the order. All right, so say you placed your order on Amazon. Once everything goes through, your credit card works, they say great. Down the line, someone is sent to get your item or a machine grabs it, it's packaged up, address label slapped on, and it's sent to you. There's your output. So this is our second objective, and we're going to talk about the evolution of computer hardware by looking over the 4 generations of computers and their associated technologies. So think about it. When did you first use a computer? How old were you? Did you have a computer at home? I know we didn't have a computer at home maybe until the early 90s, and it looked like this, but more gigantic. Okay? The technical and scientific advancements of the Industrial Revolution really pushed the development of mechanical computers. In 1801, Joseph Marie Jacquard invented a mechanical loom that used punch cards to manufacture textiles with complex patterns. The Jacquard loom was revolutionary because it was a machine that could change its weaving pattern based on an algorithm. And an algorithm is just simply a set of instructions that the computer follows, almost like a recipe, okay? Step by step by step. So you hear that term a lot in computer science. So this algorithm would let the loom know where to, do this pattern and where not to do that pattern. And so this was a really amazing machine. And here's a picture of the loom, okay, and the little punch cards here. Right. Charles Babbage was an English mathematician, and he originated the concept of an actually programmable computer. He imagined something called an analytical engine that could calculate series of numbers. He had an accomplice, or associate rather, and her name was Ada Lovelace. She ended up writing a program for this analytical engine that could calculate these series of numbers. Okay? So we actually consider her to be the first computer programmer. Unfortunately, her program never actually ran because the analytical engine was never completed. The design, which you can see right here, this is a picture of his design, actually surpassed the technology of the time, and so they weren't able to build it. It just remained a plan, basically. Later on, down the line, once the technology reached, the plan, they were able to build this analytical engine. And this is what it looked like. So big and, in my opinion, beautiful. Okay, and this, all it did was calculate series of numbers. Alan Turing believed that machines, which were later called Turing machines, could perform mathematical computations. In 1950, he developed the Turing test to assess a machine's ability to display intelligent behavior. So for this forward thinking, many consider him to be the father of computer science and especially of artificial intelligence. And just an FYI, artificial intelligence is the science of making machines behave like humans. That's going to include your robots, all different types of things. In June of 2014, so just 3 years ago, a computer by the name of Eugene became the first computer to pass the 64-year-old Turing test of intelligence. This is Eugene. And Eugene was a computer, and he was programmed to act like a 13-year-old boy. All right, so you would type in your question here, and then Eugene would reply. And they had a lot of scientists take this test, basically. And at the end, they would ask them whether they thought Eugene was a human or whether Eugene was a computer. Eugene managed to convince 33% of the judges that he was a human. So this was a huge step in artificial intelligence. Okay. With ever-increasing computer power, huge developments in software and improvements in voice recognition and artificial voices, we have to accept that before long, we're going to be chatting to machines without a single second thought. Okay, I mean, we do it already. People say that by the time we reach the end of our lifetimes, or at least by the time our children reach the end of their lifetimes, they will definitely be living with a robot. So we'll be talking to these machines. All right, so let's move on to the generational computers. First generation computers used something called vacuum tubes. And the first computer in this generation was the Z1, which was developed by Konrad Zuse. John Atanasoff and Clifford Berry followed with the Atanasoff-Berry computer, also known as the ABC, in 1942. Okay, so we're just following this timeline here. Colossus was used by code breakers in World War II in order to decrypt German messages. Colossus was extremely top secret and was actually destroyed once the war was over. We really only learned about its existence during the 1970s. Okay. So it's really interesting. If you have some time, you can do some reading on Colossus. All right. In 1944, we have Howard Aiken, who invented the Mark I. John Mauchly and Presper Eckert created the electronic numerical integrator and computer, which was called ENIAC, this right here, in 1946, and then followed it in 1951 with the UNIVAC. So this picture right here is a small portion of the ENIAC. Just fun facts, and to show you just how massive these machines were. The ENIAC used over 18,000 vacuum tubes. It weighed over 30 tons, and it occupied 1,800 square feet. They originally had designed it to calculate artillery tables for the war. However, they didn't even finish until the war was over. And so, thankfully, they were able to reprogram it to do other things, such as atomic energy calculations, things like weather predictions. Okay? So sort of one of the first supercomputers. Okay? Programming the ENIAC took 6 programmers several days, and it was a matter of going in and manually manipulating all the switches that you see here.